So welcome to the first presentation in the PDF University track. We'll start right on time to have as much time as we can during our slot. The PDF University track has a number of quite different presentations covering various topics, some more technical details, some more on a philosophical level. And the first presentation is going to be about an upcoming specification or standard, currently called PDF Raster. And I have the pleasure of having René Rebe here, who will give the presentation. René has a strong background in scanning, image processing, OCR, and so forth. In his earlier years, he was very active in the open source community. And I think for the last 10 or 11 years, they've been running their own company called ExactCODE right here in Berlin. So there's a lot of good stuff in Berlin, actually. René is not only a member of the TWAIN organization, the leading trade association in the field of scanning systems, but also serves on the board of directors. He has been quite active in this project, PDF Raster, which is a joint project between the TWAIN organization and the PDF Association. And I'll hand it over right away to René to tell us what this PDF Raster thing actually is.
So thank you much, Olaf, for the introduction. So I can skip over my own introduction. Yeah, my name is René Rebe from ExactCODE here in Berlin. And today I'd like to introduce what we in the TWAIN working group have been working on the last years. So actually it's also covering a little bit of TWAIN and TWAIN Direct. So you can, if you're not so familiar with this scanning terms, you can maybe also learn something new a little bit aside of PDF documents. No, the keyboard connected, okay. So yeah, I founded ExactCODE here in Berlin some 10 years ago. A little bit introduction anyway. Mainly from embedded Linux, but as it often happens, you found the company and then you get different inquiries. So we processed more to image processing and scanner drivers over the years. And since 2005, we also have applications for end users. ExactScan is a scan application for Macintosh with 400 scanner drivers. So you can use all those professional scanners from Fujitsu, Canon, Panasonic, Vision, Xerox, also on the Mac, that otherwise only work on Windows PCs. And we also have a small OCR tool for fast batch OCR processing. Yeah, last year, 2015, I was actually invited to the TWAIN working group as a board member because most of the TWAIN member companies only work on the Windows side. And they wanted some company and a developer to also help them promote TWAIN and develop TWAIN for Mac and Linux systems. And as we are one of the main companies doing this on Macintosh, we were asked to join to help them there. Some brief background about TWAIN. Who knows TWAIN of you? Maybe all, or? So TWAIN is actually one of the major standard scanning APIs. Actually, it is also quite old, since 1992, so about as old as PDF. It was started in the early days of PCs when the few first scanners all had an own API and one software did not work with the other, similar to PDF, one could say. And there are other scanning standards. Microsoft recently introduces Windows via Windows Image Acquisition, and Apple also made an own image capture API for Mac OS, but the problem with those is they are not as full-featured, and obviously they lock the vendor into this dedicated platform, this operating system. So TWAIN still plays a major role allowing application developers and solution providers to have the same standard to work with on all platforms. So historically, TWAIN mostly works with raw image data in the computer's memory. There is a way to transfer a bitmap on Windows and TIFF on Mac and Linux, but this is more the fallback legacy simple API. It's not really so recommended and used in real applications. So since the last years, the TWAIN working group was working on a new TWAIN standard, and in a minute I show you why. Obviously, the industry is developing very fast, it's transitioning more to a mobile world, and the first non-PC scanners appear, network scanners, Wi-Fi, wireless scanners. So right now the vendors have, each vendor has an own solution, so obviously it would be great if with one application on a tablet or an iPhone or even a PC, you could use any of these network scanners, and especially on mobiles and tablets where you normally can't install a driver. So for this cloud world we are transitioning to, the TWAIN standard working group wants to propose a solution. So the classic TWAIN API that you get an understanding why we actually want to use PDF and where we are coming from. So it's a typical C-style API. If you're a developer, you probably get the idea with enums and structs and bits, and you have pointers in memory and fiddle around with them, fill them with values. So obviously this is relatively complicated. Developers naturally need to spend some weeks or months to get it working. If someone's creating a new application for some database, what they want to sell to customers, they need to spend a significant amount of time to actually get the scanning working. As I said, nonetheless, it's a de facto industry standard API for scanning, and of course, scanners can have many functions. Obviously, the API needs to be relatively complicated because it needs to deal with all the possibilities of big and feature-rich scanners. So what are we talking about? So I have here only one slide. I don't want to bore you any further with it. So this is, if you're a developer, so this is C, this is actually a copy, I didn't make it up, it's actually a real example from the TWAIN standard. And you have some structs, you fill in there some capabilities, and like feeder, flatbed, ADF, color, grayscale, and bit depth, and so on. And so there are like 200 also capabilities that you negotiate with a scanner. So yeah, things become rather complicated quickly. So innovating forward, what we've done the last years, so we created a modern scanning API from scratch. The last years we hope to finalize it this year. It is simple and direct, you have seen the example. So the C API was not so simple and not so direct. You negotiate a lot of things with bits and memory. So what we have created for the cloud solution, we created a JSON API. This is a JavaScript object notation, so you don't have to deal with any bits and pieces in memory anymore, which obviously doesn't work very well over the network and the cloud infrastructure. So you can now describe your scan task with JSON, with JavaScript object notation, and we use this as an API to control the scanner. This also completely eliminates installation of a vendor-specific driver. So right now, today, on your PC or Mac, you need to install the Fujitsu or Canon driver to use the scanner. So with this new JSON style TWAIN Direct API, you don't need a driver at all. You can directly start to scan from a tablet or a mobile phone or even your Mac or PC. And it also for direct network communication. Also, even if it's not on the same LAN, it can be over the cloud, over LTE. Your customer or your service technician can go to some customer and can scan directly with a tablet the invoice document or contract document, and it allows to do all this over cloud platform. So TWAIN Direct is also entirely different from the classic TWAIN in that it emphasizes success. So with the classic TWAIN, you negotiate capabilities, and if everything goes right and you agree with the scanner driver, you may at the end transfer an image. So with TWAIN Direct, that's entirely different. So scanner should, in any case, always deliver an image, even if there is some disagreement with some detail, like the resolution or the color mode. For a cheap scanner may only scan gray, and we want that the user always has success with scanning the document. So unless the application has a very good reason to tell the scanner, okay, if something doesn't configure like I tell you, then fail. The default use case is to always get an image and have success for the user. I have here a small example how this looks like in this JavaScript object notation. You have an action like configure and scan. You define an image stream with the resolution, the source like flatbed and ADF, pixel format like gray color, and various other attributes that you may want to define. So this already looks much simpler than the classic TWAIN that you are used to work with right now. And in one slide, the most simple scan task that you can send to the scanner looks like this. So compared to all this bit fiddling from the PC world, you probably agree that this is much nicer and simpler. This can be, if you don't care about quality and settings, this is the most simple API call that you can use with TWAIN Direct to get the image data, the scanned paper from a new scanner in the future. So this is all great, no more memory and bit fiddling, not so much can go wrong, especially no pointers, no easy crashes and so on. And we want that users and system integrators can get an application, a new database application, simple front-end running in days instead of weeks or months. So now we have all this infrastructure in place, but we need some way to transfer the image data, right? Because before that was in raw computer memory, so what do? Naturally, the first look was a TIFF. What I didn't know, and I only found out in this discussion, was TIFF was actually created by scanner vendors in the mid-1980s. And initially it even was black and white. I did not know this either, because in the 1985, 1986, when the first TIFF format was defined, normal PC scanners could only scan black and white. Gray and color were much more expensive and came much later to the PC. But the problem with TIFF is there is no universal browser support. So if we want to work in a post-PC world with tablets and mobile phones, not having native support in the major browsers obviously is an issue. So right now, today, even Mozilla Firefox and Google Chrome still don't support TIFF. They support other formats like JPEG and PNG, but not TIFF. Google Chrome and Firefox, I think they both just download the file and save it in the downloads folder and will not display to the user. And also, many scanner vendors knew from experience that even this format is very old, there is still compatibility issues with black and white interpretation, especially if the image data is CC, ITT, flex compressed. Then some not so well-tested libraries and applications can easily display the white background as black and the letters white. So obviously this kind of things is something that is a showstopper if you want to promote a new easy scan API. So okay, we better look for something else. Of course there are other possibilities. Instead of PDF, PNG, JPEG, JPEG 2000, Windows bitmap, but they all have a problem. The first problem is most of them only allow to store a single page. Obviously, usually people scan more than one page, so that's also an issue. And they all have limited compression options. PNG is always separate, JPEG obviously is JPEG, JPEG 2000 is JPEG 2000. Okay, in BMP you can store different compression formats, but nobody really supports this, and only a single page. And the biggest concern nowadays with security, especially over networks, people want encryption and signatures, so none of these file formats supports this natively. So we quickly turn to PDF. There's wide support, many viewers, many tools, many libraries, a whole industry working with this format. Also, TIFF has a problem with endianness conversion, so TIFF can store little and big endian, and half of the tools don't really work with this or have bugs with this, so PDF doesn't have this problem either, and PDF also allows to store multiple images and pages, and also p-tonal images, actually, in the previous slide. So if you would use JPEG or JPEG 2000, I think both don't support black and white data, and if you store black and white data, you get a fuzzy image. Obviously not very nice for the user. And we have many compression options, so we can store CC-ITT, compressed text data, setlib, JPEG, JPEG 2000, JPEG, so many options to choose from. And we can also, a very nice property from PDF, we can store most image data like it comes from the hardware. Even if it comes from hardware, CC-ITT compression of the scanner, or some scanners even have JPEG compression, you can just put it in the PDF container and are done with it. Very nice, especially on a small scanner. It supports inscription, digital signatures. So with TWAIN Direct in the future, you could directly sign the PDF on the scanner. You put the user certificate or a company certificate and already signs it. The user scanned it with this scanner in the bank, in the insurance processing station, or in the government tax authority or wherever, and you can actually track who scans this document and really have an authoritative answer to this. And we can store additional metadata. It's also a problem with the other formats. They allow to store some keys and values, but this is rather limited. So with PDF we can store any XML data or other metadata, which is rather important in the scan processing for barcodes, for additional information that may already be available when you scan the document. So at this point you may wonder, okay, PDF is great, everyone knows this, but why do we need a new standard? So the PDF standard is quite complex. Developers of you working with PDF probably know this. So the PDF standard is very long, 748 to 1,300 something pages, depending on which document you're looking. ISO standard, Adobe, the older Adobe PDF guidelines. And it allows for much more than we need. It allows for text, vectors, patterns, gradients, multimedia data, audio, video files, 3D, forms, JavaScript. So while this makes PDF a very great format for sharing Office documents and filling out text forms, that's a problem in the scan processing in two ways. So the first way is a simple one. A scanner is usually a relatively low-cost device, or even if it's an expensive scanner, it still does not have so much CPU horsepower to work with. It's like 40 megahertz, 100 megahertz clock for entry-level scanners, only some megabyte of RAM and ROM, so really PC from 20 years ago. And while you could say, okay, you just write a simple PDF, that's true, we could just write a simple PDF, but I have a slide in a second to show you why it is good to provide some industry guidance, because if we don't provide guidance, the scanners and scanner vendors, each vendor will do something different. And if everyone is doing something different, this sooner or later leads to problems, to compatibility issues, and may hinder adoption and developers and users using this new standard. But the much bigger problem than creating these PDF files actually is extracting the image data, because scanning your paper is only the first step in the processing chain. And when you work with this kind of raw images from the scanner that may not have an OCR or barcode recognition from a very cheap entry-level scanner, you want to get the original image data. Because if you take a regular PDF, there may be more than one image on the page, and then you start to need a whole PDF, like a viewer, like an Acrobat viewer, to rasterize all this image data. So if we don't provide guidance, we cannot easily guarantee the extraction of the image data for further processing. And so this is the much bigger problem than generating the file. And also mobile devices may not be so powerful to do the full PDF rasterization quickly. And for cloud applications, the problem is if you run a bigger server farm, you have a big application, government application, bank application, you have hundreds of servers, the more processing power you need to process all your scanned data, the more expensive it becomes to you. And if we can limit what appears in the PDF file, it also improves security, because the less features you need in your PDF workflow to actually process the scanned data, the more security risk you have, because each feature adds to the code base, and the bigger the code base is of your solution, of your libraries, the easier it is for some attacker to find some flaw in it and use it. So actually this part of our solution we want to provide is a more difficult one, and what kept us thinking to limit what can be done in this PDF raster. I have some examples for you to show you why, if we would write in the TWAIN direct standard, if we would just provide the guidance, okay, only store images on the page, this still leads to problems. So on the first page that I sketched that for you, there is just one image in the middle. So it's still relatively easy to extract, but what do you do? The whole page in the scanner was the whole page, so for further processing, you need to either convert this to the whole page, or it's always a problem if you can't reuse it one-to-one. The next example, the image was a little bit bigger and is cropped, and in your further processing flow you would need to analyze this and either with a full PDF library or just crop it, reduce this image data. A scanner may also place tiles on the page that you may need to combine. Then paper never goes 100% straight through the scanner. You will always have some page skew, even if you have a really expensive machine with some skew compensation. So the scanner scanner vendor may be clever and actually store the original data with some transform to compensate for the skew. So if you're going to process this image, you need to have some image processing to rotate and crop your image. And even worse, and I've seen all this in practice, the last example I want to show, even if the image is relatively straight on the page, on the PDF canvas, the beginning of the page may be in color, and then it may be a fancy copy machine, and the copy machine may notice, oh, the rest is only gray, and it continues with a gray image. So dealing with all this complexity obviously is something normal application developers do not want to do. So the less complexity you have in this file transfer, the better. So on the bottom, I sketched two scenarios that we want to support with PDF raster. The one is the image. There's only one image per page, and it covers the page boundaries perfectly, which is of course the ideal use case like you have in JPEG and TIFF today. And the second case, we also want to support, these are stripes of images exactly with the same dimensions underneath each other. We want to support this for two reasons. One reason are very cheap scanners, 70 euro, 100 euro, that you even scroll manually over the text canvas on the desk. There are quite some scanners on the market with this today, even with Wi-Fi functionality. So the processing power may be so limited that it cannot compress the whole page and it needs to compress small fragments. And even an expensive scanner may do so. Modern scanners allow to scan 1 meter or 3 meter for medical records or other industrial documents, like from oil rig drills, like some curves. So customers really have 3 meter long scans, and if you have a 3 meter long scan, it is also nice if the scanner and application can store the images in small stripes. So the last reason what got us thinking to really provide some guidance here is some of these cheap scanners I mentioned, they started to produce PDF natively, and the vendor proposes, okay, dear application writer, if you want to extract this image from this scanner, it is actually super easy. You just search for the string color space /device RGB /filter, And if you found the string, you skip over the white space, you pass this number there, and then you remove the trailing bracket, and you have your compressed JPEG data. This is actually from a vendor document, my most favorite document, and this is obviously not something that we as an industry want to advertise at large, and why we want to provide guidance to write a proper PDF and to provide small and simple tools to deal with this properly and not do pattern matching on documents to extract raw image data. So our solution, so we looked on the PDF standard and really removed everything we didn't need. We don't see any need to use if we are looking for a TIFF replacement to only store raster data. So we scratch everything, all support for anything that is not related to raster data. And right now this also means we, in the initially revision, we also do not allow JPEG 2000 and JPEG due to complexity concerns. Also, just on Monday there was a new security issue in the Google Chrome browser related to JPEG 2000. So in the beginning, the less highly complicated compression formats we support, the better. So we support the standard compression formats, JPEG, and if a vendor, scanner, and application writer want to use more advanced compressions, they of course can do so. They can still negotiate to use a regular PDF, but for the initial revision of PDF raster, we want to make sure that the solution is simple, and using this in scanners and mobile devices does not place additional complexity burden to the application developer. So we also did not add anything new. This is also very important for us because we want that the PDFR work with any existing viewer and toolchain and database setup that you may have today. So it's a true subset of PDF, and it works with any existing viewer and tool, and it's just meant to provide industry guidance for this scan workflow case, and it can of course replace any use of TIFF and JPEG files in the future. So the new standard we are working on is electronic document file format for multi-page raster image documents, or simply PDFR. The only additional comment in the file is a PDF raster marker for the case for the application to quickly check that it's really the PDF raster subset, and it wants to start processing the file. Of course, if there's a multimedia content in the middle of the file, the library will, of course, raise an error and indicate to the user, okay, this document is not something I want to process. And for the simplicity reason, to check quickly that it's PDF raster, there is a simple comment. Right now we will probably place it at the bottom of the file for the reason that if you modify the file with a full editor suite like Adobe Acrobat and it writes an incremental update, that you will not find this marker at the bottom anymore. If it would be in the front like we thought initially, incremental updates would still indicate it's PDFR. So these are the small details that you figure out after some months of standardization, and that's what we are looking right now. So after removing everything, what does PDF raster still support? So PDF raster still supports multiple pages, multiple images. It supports ICC profiles. Initially we wanted to also skip over that and would declare that image data is always sRGB calibrated. But some scanner vendors raised the concern that they may want to support higher color fidelity, so we added back support for ICC profiles. This affine transforms, so any transforms are not supported. You cannot skew, rotate, translate, or otherwise perspective transform the image data. For the reason I outlined earlier, the application wanting the raw image data should be able to access and extract it quickly without any additional transforms. So no cropping, the images need to be exactly positioned on the page with the full page boundary, and the image data needs to fill the PDF drawing canvas entirely. All these mechanisms allow, as mentioned, and as is the goal of the standard, allow to easy access the image data as it were a TIFF or JPEG file, and no additional page content stream parsing is required. There is, of course, a page content stream just showing, as PDF developers, libraries and tools probably know what I'm talking about. If not, you can, of course, ask to outline this in more detail. There is a page content stream, but the only operators allowed are those necessary to display the image next to each other, on top of each other, to make normal PDF viewers and tools use the images. The simple libraries like TIFF and JPEG, like libraries working with PDF Raster, do not need to pass the content stream. That was our biggest concern, because if you want to run the OCR or barcode recognition and so on, as less content stream parsing and rasterization of image data with transforms you need to do, the better. So you don't need to look at the content stream, it is there, but you can just use in PDF Raster, you can rely that the images are in order, and you can extract, just take them, and if there are multiple strips, combine them, and you have the original image data without any loss or blurriness or filters as it came from the scanner or image application. And as
Good question, yes?
Yeah, if you do that, then you've created a situation whereby a PDF raster processor will generate a different output image for the exact same file than a file that processes it according to the rules of PDF, because you're not dealing with because my assumption, when you do the do operator, when you put the image down, you have to have a CM to do it. You've got an affine transform, I'll buy it at a scale, but it's a basic transform, which is going to change the result in terms of the actual output pixel ratio against the actual raw image data. So you're going to end up with a potentially scaled version on the assumption that you want it to fit on an 8.5 by 11 or something sheet, depending on the output resolution. So everything up there is perfectly fine, except for the fact that you're ignoring the page content stream. And that concerns me significantly, because I would expect the output from a raster processor and the output from a standard processor to be identical.
I don't really follow your concern. Maybe you can explain it in more detail, or we discuss it later in more detail. So basically, so transforms except scaling the image are not allowed, so the image can only be scaled proportionally to fill the page entirely, so it cannot be like one side was like 50% or so. So it only changes the output. So why we do this, we want to reuse the raster data as it came from the scanner. If, as you said, if we would, with a normal PDF workflow, rasterize the content stream, it may lead to blurriness or very small pixel duplication because of, as you described, the placement of the raster data or anti-aliasing issues of applications working with anti-aliasing.
But that's my point, René. You've got a raster processor that does not process the content stream will end up with a different presentation of the page content than a processor that processes it according to the PDF rules. Mm-hmm. And since you are creating a pure subset, which has been a big part of the design of this from all along, there's this file can just as easily and should be able to go into a standard PDF processor. If a standard processor and a raster processor come out with different results, that's bad. And we don't want that.
I think I understand what you want to refer to. So, of course, the output, as you described, the output can be different, so it's not like pixel precise, as you described. But this is exactly the reason why we define PDF raster. So as I outlined earlier on my image sketches, I could also go back to this here. So as I want to show with this not 100% aligned images, as you described, if it falls a little bit off the pixel grid, you always will have some alignment issues, pixel duplication, depending if you have an anti-aliasing rasterizer or not. So this is exactly why we define this format. So if we don't have this PDF raster format, you will usually never, like nearly never, never say never, but you will not easily get to the original raster data if you raster your page content stream. And so what you described is exactly the problem we had working on the PDF standard, because if you are dealing with raw image data from a scanner or digital camera, you want to continue using this data to OCR, barcode, recognize. And so as you described, if you evaluate all the page content stream and rasterize it according to the rules of the PDF standard, you will like nearly next to never gets original data. So this is what the standard is about, and as you described, yes, so if you like view it in Adobe Acrobat, the visual representation may be not 100% pixel perfect for the reason Acrobat showing it with its rendering constraints on the display's pixel grid or printer pixel grid. But so what we want to do is exactly allow for extracting, getting easily to the original data for further processing. And I think the standard allows for this. It allows for using existing tools and still yet gaining easy and direct access to the original data for further processing. And in my end, I guess most others, TWAIN working group definitions, this is what we want to achieve, and that a viewer may show it slightly. I mean, even every JPEG viewer will show a JPEG differently, or a TIFF will raster a TIFF differently on a display. But PDF raster still allows for this. So the file shows 100% perfect, as much perfect as a display or printer can represent the data, and yet you still have easy and direct access to the original data.
I have a similar question. So from what you said, I understand that the images in your PDF files do not have a resolution. For example, in a TIFF file, I can say my image data has, for example, a resolution of 300 dpi that maps it to some physical size. And it sounds like there's no mechanism for that in your PDF.
There may not be a direct.
And I have another question. Similar, if I turn it, if my scan is upside down, the only way to make it look right in my viewer would be to change the image data, or would there be a mechanism to
yes.
There's some transformation made.
Yes, to answer, so your first question was
scaling.
Scaling. The resolution can be defined because you have the width and the height of the images. You can compute the resolution from the page boundary. The PDF is physical width in this postscript points, so you can compute the resolution from that.
No, it doesn't. That doesn't. Your math is wrong. It doesn't work, René, because you're not scaling your pixels. You have no units because you've taken out the page content. Because you've taken out the content parser, you don't know what the user units of the page are, which means you can't compute the resolution correctly.
You have the media box.
But the boxes described the boxes units aren't necessarily the same as the rastering units because of the whole point of transforms that describe from user units to device units. Your math doesn't, he's completely correct, Christoph is correct, because you don't take into account the transforms inside the page content stream, you can't determine the actual output resolution of the content.
Well, our impression is that, so the bounding box is in postscript points, so it's 17.
No, it's in arbitrary PDF user units. They're not points and they're not postscript.
hang on. So it's good to have a discussion.
But it's good that we have some detailed discussion. I mean, we still working on standards, so any input is welcome.
Just wanted to contribute a little bit. So we disallow user units.
So we disallow user units in PDF Raster intentionally. So we also require that the image on the page fills the page exactly as defined by, I don't remember whether it's just said the media box or the crop box, but either way. And if you can rely on the fact that the image will stretch across the width, and if it's just one image across the height or the combined strips across the height of the page, then you can indeed compute the resolution, because then you will have the postcode point. So we have been doing this forever, like the effective resolution. So that I would insist that it just works. So I think the resolution is covered if you combine all the rules that are written down in PDF Raster. So there's not an entry saying resolution of 300 dpi or ppi, but because you have the rule that the image stretches across the page, and you can only use the transformation matrix to achieve that and nothing else. So no other transforms. And you can only have the do operator to put the image on the page, and you must put it on the page so it starts at the upper left and ends on the lower right and completely fills the page area. Then you can do your math and then actually derive the effective resolution. So in that regard, I would claim that it just does work. And then also in terms of the end result, so to speak, processing such an PDF file using a PDF Raster specific tool, and then using a general purpose PDF processor/viewer, to the degree that two viewers would agree, which they don't never do perfectly well, but to the degree two viewers would agree, like Foxit, Adobe, Nitro, whatever, I would also claim with René that on the same level, a view created from a PDF Raster specific PDF processor would agree with Adobe Reader or Nitro or Foxit. So I think within reason, it's perfectly valid to make these assumptions.
So what happens if you would save a PDF raster out of Acrobat and then open it again? Would it be different?
It would most probably not be a PDF raster file anymore, because we are using a certain comment in a very special way, and we're still discussing that. Because a non-PDF raster-aware processor would not write the comment again. It would either not be there if you write a completely new file, or if you do an incremental update, it would not be towards the end of the file anymore, near the end of the file. And in order to be a PDF raster conforming file, the comment has to be near the end of the file. So if Adobe Reader or Foxit or whatever, or some other tool creates a derivative of the PDF raster file by writing a new file or an incrementally updated file, it will officially not be a PDF raster file anymore, and the PDF rasterness will not be guaranteed anymore, and you should not assume that you can do the same things, you can still do the same things you could otherwise do. Any saving process may then add annotations or reorganize the page streams and do rotation, whatever. You can all do that, it's perfectly valid, it's expected behavior. So I think both TWAIN and the PDF raster and PDF session expect that tools will do stuff with PDF raster files, like add OCR and whatever. It will just not be a PDF raster file anymore, it will become an ordinary PDF file.
So you will not be able to view it in a PDF raster viewer? Maybe.
If it's really
maybe not
PDF raster view that only supports PDF raster, nothing else, they will probably say, I can't process the file.
So to answer the other question with rotation, we do support the rotate entry in the page dictionary, so you can still change the orientation if it was scanned upside down or
by
90 degree, yes, 90 degree, like you would do in a TIFF or JPEG file with JDEC is not what it's called. So you can rotate the data by 90 degrees, and yeah, it would not, with a pure PDF raster file, it would or should normally not process anymore, because this like driver, even so far in the future, scanners may use PDF raster as main transfer medium, and then it could even be that the Windows driver or Mac driver receives PDF raster, and it obviously does not want to receive something else. So if you doctor with a file and add there something additionally, save it with Acrobat, then even like a device driver would not accept it anymore. Obviously, it needs to be still securely programmed, and it would raise an error if it indicates something in the middle of the file that should not be there, like an audio file. But the point is, of course, to check it quickly before we start expensive processing. Yes, please.
May I just confirm, this special comment is the first line of the PDF file?
No, initially we thought the first line, and we had this for like a year in the standard, in the draft, but later discussing this, we figured out the first line is not a good idea, because if you save the file again with Acrobat, it's still there if you make an incremental update, so this is why we moved it to the end of the file. And it will probably be in front of the trailer dictionary, probably. So if you write an additional trailer dictionary, it will invalidate the PDF raster marker. I wanted to shortly come back to the TWAIN Direct to give you an idea. The initially scan example looked obviously overly simple, yet it will still work. So a real world TWAIN Direct scan task will look a little different. It will have a configure action. All these braces are the nature of JSON, a little bit like Lisp, you could say, a little bit many braces there. But aside from this, it's human readable. You define streams and sources, like AEF or flatbed and pixel formats. So and the default behavior is to try each of the configure values in sequence, and the first that configures matches and is done. So if the scanner supports RGB scanning, it will configure with the pixel format RGB. If not, it will process to the next sequence, try to configure with Stray 8. If that still fails to configure, this example will still proceed with the scanner's power on default. As I outlined earlier, our new goal is to always emphasize on success. So the user still gets a scanned image, even if any of these configure statements does not configure in. We think this JSON JavaScript object notation is much nicer to work with for developers than the old C API, and is our transitioning to maybe post-PC. We will see more mobile world. And you may ask the question, okay, what happens if I really want to scan something where I want an error? I have also an example for this. So you can configure in this JSON to throw an exception if the scanner cannot fulfill your wish. In this example, it's readable, big enough. We set a resolution, and there you see an exception specification, exception fail. So if the scanner is not able to configure with 300 or 200 dpi in this example, you actually will get an error. You can use this, for example, if you need to make sure to scan with 300 dpi for OCR, or if you want to make sure to scan with duplex with the front and rear camera, you can fail if the scanner cannot support what your application needs. So, however, with TWAIN Direct you can still use other file formats. So, for example, you can still configure, if you have a very fancy machine, €3,000 copy machine or so, that can output a real PDF, maybe even with OCR layer. We support a mechanism to negotiate something else with this configurations in PDF raster, like a full PDF, possibly with OCR layer and JPEG 2000, but then the application really needs to make sure that it can deal with all these additional PDF elements. Yeah, PDF, obviously, it is not only for TWAIN Direct. This is just where we defined this, and so it's useful for the industry as whole. Everyone can just use it in their applications, theoretically also to share photographs. It is for guaranteed image data exchange to make sure there are not vector elements, gradients, patterns from cat drawing or whatever, and it can possibly replace all the other existing TIFF, PNG, JPEG file formats in the future, and simplify workflow with digital image data, pixel data, and we think it's a quite nice universal raster file format for image interchange. Yeah, thank you very much. There already were some questions. If you have more questions or concerns regarding Pixel,
I have a question. Do you already have some performance measures between the original C-based API and the JSON-based API?
We don't have performance figures. Right now, I'm not sure if there is a scanner out yet. We are still working to finalize TWAIN Direct. And also the goal is entirely different. So TWAIN Direct right now is focusing on mobile scanning. And on these mobile scanners, you don't have high performance anyway. And the really big, the regular office and production scanners will, TWAIN, the classic TWAIN will not stop to exist tomorrow. There is a bright future. We will, this summer, soon the end of the summer, ratify the 2.4 standard, so we still refine and push forward the classic TWAIN standard. It's just an entirely different feature set right now, and obviously if you do network scanning, the performance for network scanning is usually a little bit lower than direct USB scanning. But we envision that in the future, this TWAIN Direct scanner could also be used for any normal scanner. So even over USB, a vendor could in the future use this to also simplify their Windows driver, Mac driver, and use TWAIN Direct directly on the USB cable and transfer JSON data instead of binary packets. And then the performance is the compressed image data. So it doesn't really matter on the USB bus.
So I understood you have these two parts. You have this JSON-based protocol and you have the special PDF format. So in your last but one slide, you said the client can request a regular PDF instead of PDF raster. So why can't the client also request, for example, TIFF? So assuming that the scanner can provide TIFF.
Yes, so in this TWAIN Direct standard, the only requirement for a scanner to support is PDF raster. So it does not have to support TIFF or JPEG, because for PDF raster we also have JPEG compression. Most tools, TIFF tools don't usually work with JPEG compression. So to support all these use cases, we focused on PDF raster. I'm not sure if there will be scanners supporting TIFF. We more see scanners potentially supporting full PDF. If a vendor wants to implement outputting TIFF, they could theoretically as a vendor extension and allow applications to negotiate TIFF. From my TWAIN view, I'm not sure if vendors will really implement TIFF. They rather would implement full PDF and support JPEG 2000 compression, JPEG compression, or even OCR layers directly in the scanner. And TIFF has no benefit compared to PDF raster. It's PDF is just a container format, and you still have the same pixel format, and PDF raster are nearly identical, or even I think you could probably convert most TIFF files one-to-one to PDF raster without any loss of transformation, even if they are striped.
Yeah, I understand the focus is not on supporting the old formats, but
yes.
Would be no. Looks like it would be no problem.
As this
in the protocol.
In TWAIN Direct, there is so you can at any attribute you can have vendor extensions with some UUID, so a vendor can implement there whatever fancy. If the scanner can also 3D print plastic or so, I mean theoretically you could censor anything you want. You can negotiate whatever. So even endorser, imprinter, anything. What the vendor may, so even TIFF, JPEG, even Google WebP or any other fancy format they want to support, yes, you could negotiate whatever you want.
Did you do any comparisons between, for one particular image that would have been previously delivered as a TIFF, the size compared to the PDFR format?
We may not have scientifically compared it. As a developer, I would say PDFR may be a few bytes longer, but not many, because in TIFF you have this very fixed text structure. I think the tag is like 12 bytes or so in TIFF, and so this is PDFR has a few more human-readable constructs around it. So PDFR may be 50 bytes longer or so for the same data. okay, maybe 100 bytes, but it's not much. So if you have a megabyte compressed data, 50 bytes more or less, obviously don't make such a big difference. And for us, the benefit is using all the industry tool chain. You can directly use it in the PDF tool chain without any additional conversion step. So it greatly simplifies all the scanning workflow infrastructure. Yes, please.
Yeah. I understand it's an exchange format, and I understand it's part of the document creation or scanning lifecycle where it comes out of the scanner onto the host computer, let's say, and I understand that. But then it actually ends up in a scan software or something, or a post-processing software or something like that. Do you expect any PDF raster formats to actually be stored in archives or even to leave scan software? Or do you expect that in the scan software it's converted into a proper PDF with all the additional functions?
So, from aside some minor discussions about rounding or rasterization of one issues, of course PDF raster is a proper PDF. It's a fully functional, completely valid
No offense, sorry.
PDF, yes. We still have some discussions about pixel precision of transforms, but we, from the TWAIN working group, we think they are like minor concerns. We're really speaking about like maybe off by one, or again, this is like swim PPIs. I mean, normally there is nothing off by one. This is only like theoretically if you have stripes. So, and we would expect actually that this PDFRs, it depends on your workflow. If you have a very simple workflow, I would think the PDFR files may directly go to some database. If you have no further processing, I think users will probably use them directly, especially on mobile phones and tablets, where today you already can get a PDF from a scanner directly, so this PDF will probably be used one-to-one for further sending and storing. And as they are a full PDF, there's nothing wrong with this.
Do you expect that digital cameras and mobile devices will deliver PDFR in the future instead of?
Yeah, well, actually, this is a fancy idea. This is why I mentioned it here a little bit. Of course, they could theoretically. Maybe in, I don't know, 20 years we really see this. People really don't use JPEG and use a full PDF container. So it is possible. And
have you seen any interest of these?
Actually, we had initially, I think there were some discussions the other way around for printing. With printing vendors, they were interested to use PDFR to send it directly to the printer. I think those discussions are slowed down a little bit, but theoretically, on the other side, using it directly for printing as a print format, some printer vendors for multifunction devices are raised some interest, so maybe on the output chain could possibly be used. Just simply because then you can simplify your print engine. If you know you get PDF raster and you do not need to prepare to get something else, instead of inventing an own binary format, and some printers take direct JPEG compressed data, so using PDF raster for this could simplify MFPs, especially if they have a scan unit, then they can use PDFR for scanning and printing.
Between Direct, is it possible to obtain unique hardware ID of device? No, because with IC standard you cannot get it. No. Unique ID hardware. So after 5 years, you can say, look, this image was done on exactly this device. It's possible to obtain between the Direct.
Yes. So for example, it depends on the scanner. Sometimes, of course, users are sensitive, they don't necessarily want serial numbers in their files, but especially as we support digital signatures, from this point of view, you could, for a more sophisticated scanner that supports encryption digital signatures, you could use the digital signatures definitely to have this kind of authentication, much more than just a serial number, or really sign it with use certificates that you pre-install in the scanner, or even every user. We are speaking about theoretically, this can be really big copy machines, so they can even have network interface and use company-wide user accounts. So theoretically, if you have a really fancy scanner, you could have per user signatures and really sign your PDFs directly on the scanner if you want to. But of course, the scanner needs to support it, not each entry-level scanner will support this.
One last question, please. Yeah, okay. Well, as theoretically PDFR files may end up in archives, is there any goal to make it compatible with PDFA?
Yes, actually this is one thing we are talking about, and we're not yet sure if we should mention it in the standard, but of course there's nothing that rules out compatibility with PDFA, so PDF raster, we think with additional PDFA metadata, I think that is necessary to indicate performance, conformance. PDFR can also pose as PDFA compatible file. I think this is possible. We are not yet sure how much we mention this in the standard, how much additional wording we put in this, but we think there are compatibility issues in this regard. Okay, thank you very much. And again, I want to